With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, a person riding a car moving at 72 kilometers per hour sounds a whistle. So the car sounds a whistle emitting a wave of frequency 1250 Hz. What frequency will be heard by another person standing on the road? So the person is standing on the road. A part is in front of the car and B part is behind the car. We are also given speed of the sound in air as 340 meters per second. So first, let us note the given data. So speed of the car, as the car is making sound, so this is actually source. So we'll call this as Vs. So Vs is 72 kilometers per hour. So we will convert this into meters per second as all the data is in meters per second. So on converting, we will get this as 20 meters per second. Also, we are given the original frequency of the sound as 1250 Hz. We are also given speed of sound in air as 340 meters per second. As the observer is standing on the road, so velocity of observer would be 0. And in the question, we need to find the apparent frequency. In the first case, if the person is in front of the car, and the second case, if the person is behind the car. So we need to find F1 and F2. So before we solve this question, let us first discuss the key concept that we need to know to solve this question. So the key concept here is the concept of Doppler's effect, according to which the apparent frequency as observed by the observer is equals to original frequency times the velocity of sound in air plus velocity of observer divided by velocity of sound in air minus velocity of the source. Now velocity of observer will be positive if it's approaching the source, and velocity of source would be positive when it is approaching the observer. It will be negative in the other cases. Alright. So now let's see, we have in case A, the person is standing in front of the car. So let's say we have a person and we have car. So person is the observer and car is our source. Person is standing in front of the car and car is moving towards the observer, right, with velocity 20 meters per second. So here velocity of the source would be positive because the source is approaching the observer. Okay, so now let us find the apparent frequency as observed by the observer. So we have F equals F naught. F naught is 1250 Hz. Bracket, velocity of sound is 340, velocity of the observer is 0, divided by velocity of sound minus velocity of the source, which is 20. So now on solving, we will get F1 as 1328.12 Hz. So this is answer for our first part. Okay. Similarly, we can solve the second part. So in the second part, we have the person and we have this car. So this car is the source and this person is actually observer. Now the person is standing behind the car. So car is moving away from the observer. Here the velocity of the source would be negative because the source is receding the observer. So this will be minus 20 meters per second. Again, we will use the Doppler's equation to find apparent frequency, which is given by F2 equals, we have 1250, the frequency, bracket, the velocity of sound, which is 340, velocity of observer is 0, divided by 340 minus, now at the place of velocity of source, we will write minus 20. So here minus of minus will become plus. So 1250 bracket 340 divided by 340 minus into minus will become plus. So it will be plus 20. So now on solving, we will get F2 as 1180.56 Hz. So this is answer for our second part. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.